At 3:14 a.m. on January 19, 2038, millions of computers will suddenly think it's 1901. Not 2038. Not a glitch they'll shrug off. They'll wind the clock back over a century, and some of them will simply stop working.
And here's the part that should bother you. This isn't some theoretical doomsday. The bug already exists, right now, baked into systems running today. We've known about it for decades. And we still haven't fully fixed it.
Everyone remembers Y2K. The panic, the news anchors, the people stockpiling canned food. But Y2038 is a completely different beast, and almost nobody outside of engineering is talking about it.
So let's actually unpack this. To understand why a computer would believe it's 1901, you have to understand how computers think about time in the first place. And it's weirder than you'd guess.
Computers don't store time like we do. They don't think Tuesday, January 19th. Instead, almost every system counts a single number, the number of seconds that have passed since one fixed moment.
That fixed moment has a name. It's called the Unix epoch, midnight on January 1, 1970. Every timestamp on a Unix-based system is just how many seconds since then.
So right now, in your phone, your laptop, the server hosting this video, time is being tracked as some massive number ticking up 1 per second. Over 1.5 billion seconds and counting.
And that's elegant, honestly. One number, easy to compare, easy to do math on. The problem isn't the idea. The problem is the box they decided to store that number in.
Back in the early days, that number was stored in a 32-bit signed integer. 32 ones and zeros, with 1 bit reserved to mark whether the number is positive or negative.
And a 32-bit signed integer has a hard ceiling. The biggest number it can hold is 2,147,483,647. Go one higher, and it doesn't just stop. It does something much worse.
It wraps around. Like a car odometer rolling over from 999,999 back to zero. Except this one rolls over into negative numbers, because of that sign bit.
So when the second count hits that ceiling, the number flips to the largest possible negative value. And to the computer, a negative second since 1970 means a date before 1970. It lands all the way back in December 1901.
And do the math on when we hit that ceiling, and you get the exact moment, 3:14 a.m., January 19, 2038. That's the deadline. That's the bomb.
Hold on though, because I think people hear the date is wrong and assume it's harmless. Like, who cares if my computer thinks it's 1901? It's not the wrong date that kills you. It's everything built on top of that date.
Exactly. Think about what depends on time being correct and always moving forward. Banking systems calculating interest. Encryption certificates that are only valid between two dates. Databases sorting records by timestamp.
If a security certificate suddenly thinks the year is 1901, it might decide it expired before it was even issued, and refuse to connect. Now multiply that across every encrypted connection on the planet.
And scheduling systems can break in really dangerous ways. Imagine a system calculating how much time until the next maintenance check. If time goes negative, that math produces nonsense. Power grids, industrial controllers, medical devices.
That's the scary part. Your laptop probably gets patched. But the 32-bit chip buried inside a factory machine, or a traffic system, or an old embedded controller that nobody's touched in 15 years. That's where it bites.
Now, someone watching is thinking, we survived Y2K, this is just the same hype. And that's a fair instinct, but they're actually different bugs with different causes.
Right. Y2K was a storage shortcut. Programmers saved memory by writing years as 2 digits. So 99 meant 1999, and the fear was 00 would be read as 1900 instead of 2000. It was a human formatting choice.
Y2038 isn't a formatting choice. It's a hard physical limit of the data type itself. You can't just tell it to assume the year. The container literally cannot hold a bigger number. That's a deeper fix.
But here's the encouraging twist, and almost nobody knows this. We've already lived through a tiny preview of Y2038. A smaller version already hit, and the world didn't notice.
Tell them about it. In 2014 and 2015, some systems doing time calculations into the future, things like 30-year mortgages or long-term scheduling, started overflowing early. They were doing math reaching past 2038, and they hit the wall ahead of time.
And those bugs got quietly caught and patched, one system at a time. It proved the problem is real, but it also proved it's survivable if we take it seriously before the deadline instead of after.
So what's the actual fix? It's almost laughably simple to describe. Stop using 32 bits. Use 64 bits instead.
And the jump is staggering. A 64-bit timestamp doesn't buy you another century. It pushes the overflow out to roughly 292 billion years from now. That's 20 times longer than the universe has even existed.
Most modern systems, the 64-bit phone and computer you're using, already made that switch. Linux, the major operating systems, they've largely moved over. So the mainstream is mostly safe.
But mostly is doing a lot of heavy lifting in that sentence. The danger isn't the shiny new hardware. It's the forgotten old stuff. Legacy code compiled decades ago. Embedded chips with no update path. Data formats that still expect 32-bit time.
And that's the real lesson here, beyond the date itself. The most dangerous bugs aren't the loud ones. They're the assumptions we baked in so long ago that we forgot they were assumptions at all.
Someone in 1970 chose 32 bits because memory was precious and 2038 felt impossibly far away. Now it's close enough to matter. Every shortcut we make today is somebody's emergency tomorrow.
So no, the world probably won't end at 3:14 a.m. in 2038. But somewhere, some unpatched system that everyone forgot about is going to roll back to 1901 and break something that matters. The countdown is already running.